Hi everybody, today's video is covering lesson 5.1, which is on adding, subtracting, multiplying polynomials. The first video today is going to be very basic. I think it will be information that you already know, so it'll be a quick review. When we add and subtract polynomials, first of all, notice we have a polynomial here. It has several terms in it, and then we have another polynomial. So this polynomial has 4 terms, this polynomial has 3 terms. That's a lot of stuff. We're going to add like terms. So when we say like terms, we look for the same power. So like 5x to the fourth, well, it doesn't have another 5x to the fourth anywhere, so I just need to write that one off by itself. Then I go down, I look for my x to the third. Well, there's no x to the third over here, but there is an x to the third over here, so I can add that over here. And then I look for my x to the second. Well, this time I have an x to the second here and an x to the second here. And so a 2x to the second and a negative 12x to the second gives me a negative 10x to the second. I look for my x. There's only one of them. It's a 14 minus 14x. And then lastly, my constants is a negative 9 plus 16. That is a 7, so positive 7. And that just brings up, I did that in my head kind of slowly. You might need a calculator for this page. Okay, so the first example was just adding like terms, just straight out adding like terms, that's all. On the second example, the problem, or the new part, is on this first one we had a plus, on the second one we have a minus. And when you have a minus sign, we have to do what we call distributing the negative sign. And so you can just kind of do that in your head if you want, and I'll explain that in a minute, or you can actually distribute it. Like, I'm going to take a look at it, and I'm going to change this to a minus 6x to the third, and a negative is a positive 12x squared, and a negative and a 16 is a negative. That should be minus 16 there. So that should be minus 16. So if you want, you can just rewrite out the whole thing. A lot of people think that's easier and makes for fewer mistakes, and so that's a good idea. If you just do it kind of straightforward, just be really careful with that negative sign because you have to keep everything in order. Okay, now that I've distributed my negative sign, so I went ahead and wrote it all out, now I can do just like I did up here. I can look for my common like terms. So x to the fourth doesn't have one, so that's just going to be 5x to the fourth. X to the third, here it is. It's a negative 6x to the third. Because there was a minus here, we distributed it, we have it there. All right, x squared, we have this 2x squared, and now we have a positive 12x squared, because a negative minus a negative. So it'd be like 2x squared minus negative 12x squared. That's plus. That's going to be plus 14x squared. The x term, we have a 14x, and there's no other x. It's actually a minus 14x. And our constant now is we have a negative 9 and a negative 16. And that was the one I made that typo on here. But a negative 9 minus 16 is going to be negative 25. So again, we're just adding like terms, combining like terms, making sure we distribute our negative sign. Our next concept is on exponents. So we did some exponents a couple weeks ago, but just real quickly, remember x squared is like x times x, right? And then x to the third is like x times x times x. Well, that's x to the fifth. There's 5 x's there. That's x to the fifth. When we have a 3, and then 2 more x's, and then 5 more x's after that. 1, 2, 3, 4, 5. That makes 3x to the 7th. Okay, so here, this time I don't have to write them all out because I only have one of the x's is x to the third. So that's a 10x to the third. And then over here, it's only just 1x. We can do that, can't we? That's a 6x to the third. So that's how you multiply when you have exponents. And I bring that up because these next couple problems, we will need that skill. So our next thing is on multiplication. And we did multiplication last unit, so we know how to multiply. We just have to distribute this. This is going to be 12x to the, there's 2 here and there's 3 here. If I wrote them out all out, that would be 5. And then 3 times 7 is 21, and x to the 2 and 5 is 7. Okay, number 6, we did a lot of this. We had a couple different ways we could do it. We could use the box method. We can use double distributing. Some people call it foiling. So we'll go ahead and do that. And I know we did this a lot last time, but let's just go ahead and do this example. This is going to be 10x to the 5th plus 35x to the 3rd minus 6x to the third, and then minus 21x to the just x. Okay, and again, we want to look and see if we have any like terms, which we do. So we want to combine those like terms. That's 10x to the fifth plus 29x to the third minus 21x. Just like we did last unit, it's just I tried to include a little bit higher exponents than what we were doing with last unit. The last one is a little bit longer than all these others. We do need to know how to do it, and we will be doing it in this section. If you like the box method, then when you drew this box on this one, you would actually need 3 boxes by 2 boxes. So you have x squared plus 2 over here, and you have 4x to the third minus x squared plus 5 up here. And you can multiply it that way. And again, if you like the box method, go for it. Go for the box method. I, however, choose to double distribute. So I'm going to distribute this one, and then I'm going to distribute this one, and I'm going to see what I come up with. So I'm going to go ahead and do this. So I have 4x to the fifth. You know what? I'm going to pause there, and I'm going to let you finish this out. So pause the video here, finish this out, see what you get, and when we come back, we'll go over it. Okay, the first time I multiplied it out, I got all these terms. And then I have to look for my like terms and combine like terms. So I have my 4x to the fifth, didn't have an x term, a like term. X to the fourth is minus x fourth, did not have a like term. Now my x to the third should come next. And so it's a little bit out of order when I did it up here. So I need to put that 8x to the third next. And then look at my x squares. I have a 5x squared and a minus 2x squared. I combine those for a 3x squared, and then plus 10 on the end. And then I am finally finished. Notice the longer the polynomials are, the longer the problem gets. Okay, so just keep that in mind. The last concept for this video is concept 4, some of these terms. You do need to know these, but you do not need to memorize them. And the reason you need to know them is I might be talking like I already have in this video and saying words, and if you don't know what those words mean, then you're going to be lost. So just so you know, the term on the end that's just like a plain number by itself is a constant. That's also a phrase or a term that I've heard on tests like ACT and things like that, where the question is about a constant and people are like, what's a constant? The constant is just the number, okay? Constant. A linear, and that's a degree. The degree is like the power, and so whatever degree it is, that's the power that's on the exponent. Well, there is no exponent, so it's a degree of 0. Linear has a power of 1, like this. Quadratic, power of 2. That was our whole last unit. Then we start getting into these, which we have not started covering yet, but we will in this unit. A cubic, a quartic, a quintic, etc., etc., etc. We don't go much above that, but at that point we just start to say like 6th power. So that's what those are. We have examples here. Now another thing is, I've used this term a lot this year, is the leading coefficient. The leading coefficient is the first number, the coefficient that's on the first term. Okay, a term is, well, this is a 1, 2, 3, 4. This is a 4-term polynomial. And so this is a 3rd degree cubic, 2nd degree quadratic, etc., etc. So each one is called a term, and then the power is called the degree. That might be all we need to know for that. So just make sure you understand these. Also, the standard form means it is in decreasing order. We talked about that a little bit earlier this year too. 3rd power, 2nd power, 1st power, 0 power. All right, that's all that this video is going to cover. So hopefully some basics, just a quick review of some things you already know.